Welcome to this course on lighting essential concepts. In this chapter on dynamic lighting, and this is part 1 on, we're going to do indoor and the basics of dynamic lighting. We're going to take a look at the regular dynamic lights and shadows, so essentially the very basics of a dynamic light, stationary and movable, and basics about performance as well as quality. The level is dynamic lighting _ indoor, found in essential concepts start assets. It's once more the exact same environment. Again, it has a couple of lamp models here that have a emissive material applied to it, and this one however has a starry sky outside, but that's about it. So we're going to light this, but we're going to light it with only dynamic. So again, we go to lights, we're going to go to, for example, point lights, add a point light, and you can very clearly see it says preview. It says preview because it's by default set to stationary. Stationary is a blend between static and dynamic, which we'll get back to in a few minutes, but to make it truly and fully dynamic only, we need to set it to movable. If you do that, the preview shadow text is gone and the light is essentially finished. It doesn't have to be baked, nothing more has to happen, this is it. So this is how the light will look and will look at all times. You can move it as well and it will update correctly and as it should. So again, a dynamic light, a big advantage of a dynamic light is that you can place it while the application is running. So for example, you can spawn a light. When an explosion happens, you spawn a light. The light has a certain brightness, maybe the light fades out over time, and then you destroy the light. So you can add it and remove it at runtime. You can move it around, change the brightness, change the color. You can do anything you want with it while the application is running. It doesn't have to be baked. So all the settings you have here that we covered earlier, they're all still exactly the same, so there's no difference there. Now, there is that difference between stationary and movable. This is a little bit hard to quickly show in one of these levels because it does involve baking. When you make a light static, it is baked into a light map. When it's set to movable, it's 100% dynamic and not baked into anything, it's not baked into a light map. But if it's stationary, it is a little bit of both. Because the downside of movable is that it doesn't support any bounce lighting. You can very clearly see that here there's absolutely no bounce lighting, there's no real-time global illumination. And that's one of the big downsides of using movable. The quality just isn't really the same. What it does do, however, is give you very sharp shadows, maybe even too sharp and too unrealistically sharp, but it gives you very well-defined shadows. Static, on the other hand, gives you sometimes somewhat more blurry shadows, it depends on the light map settings of the model, and it gives you light bouncing. So stationary tries to give you the best of the both worlds. In this environment, the best example of that would have been this lamp. So what you can try, if you want to have a little exercise, is place a light inside the lamp, something like that. You can turn off the grid, by the way, it's snapping to the grid. There's a button here that has the grid on. I disabled that. That's a bit easy to place. And what we want to have is essentially this. We want to have a very well-defined shadow that comes from the cap of the lamp. Same there. But we'd still like to have light bouncing because this is rather unrealistic. This is a perfect example of stationary. But you would have to rebuild the lighting for this to work. Just to show you what would have happened, I'm going to switch to FX and reflection, finished assets. I'm going to take lighting effects _ finished. It's one of the levels of a later course, but it has the same content in there just to show you the finished result. And you can see here very clearly you have a well-defined shadow, but you also have bounce lighting from this lamp. And this is a perfect example of stationary. It's trying to give you the best of both worlds. Now, likewise, we need to have a couple of brief words about quality, performance, and the different types of shadows. This is going to become more apparent in the next chapter when we talk about dynamic outdoor lighting, but there are actually many different types of shadows. So there is not just dynamic shadows, there are actually 4, 5, 6, I forgot the exact number, but it's a relatively large number of different types of shadows. In fact, the shadow that is caused by stationary light is a different type of shadow than the one caused by a movable light. And there's a few more coming up in the next chapter: cascaded shadow maps, distant field shadows, and so on. So right now it's not that important, but just take into account that that's happening behind the scenes and it's going to affect your work later on. Likewise for performance, while we said that static lights don't take any performance at all. It doesn't matter whether you place one light or 50,000 lights, the performance will be exactly the same once it has been baked. That is definitely not the case for movable lights or stationary lights. In fact, stationary lights has the most obvious. That's the most obvious one, so let's start there. If you duplicate the stationary light a couple of times, so now we have it 4 times, everything is still working. I duplicate this one more time, one of them goes red. That's the first limitation already. what a stationary light does is it stores its shadow map, which is how the shadow is rendered, into a texture. The texture only has 4 channels of color, so one of them is now without texture to store its information in, and it's going to give a performance hit. So when working with stationary lights, it's very important none of them go red. Okay. When they go red, it means you have too many stationary lights within the same area. If one of these lights would be further away, the problem would be fixed. See, if you move it away, there is no more cross. If it comes close, it comes back. It's due to the shadows as mentioned, so if you were to turn off the shadows on it, cast shadow is false, the problem is also away. And if you switch it to movable, you got rid of the issue. So just to point it out, for the movable lights themselves, the performance is down to the number of dynamic lights and in particular the number of dynamic shadows. That's something that we demonstrated in the earlier course and chapter on real-time rendering fundamentals. So if you haven't watched that yet, please do that first after this one, because it will really show you what happens when you have too many dynamic shadows. So be very aware of that. Dynamic shadows are very, very heavy. They're one of the heaviest things you have in real-time rendering and in the Unreal Engine. And then lastly, quality-wise, as already briefly touched on, dynamic lights are not the very best for quality in the sense that they don't support global illumination, they don't support real-time radiosity. The shadows are very nice and crisp, but they're probably too unrealistically crisp. So those are all the considerations you need to have. If you have very large shadows from very large geometry, let's say you have a very large metal bridge and the metal bridge is casting a very large dynamic shadow, that shadow might lose some precision, especially on when seen from further away or when the models are very big like that bridge would be. So again, be a little bit careful and considerate with that. So we've gone through the basics of dynamic lighting, and we started out by taking a look at indoor dynamic lighting. We'll soon move over to outdoor dynamic lighting. We've gone over just the regular dynamic lights and shadows, how to configure a light to be dynamic by setting it to movable or by setting it to a hybrid between static and movable by going for stationary. When you could use stationary, for example, the lamp example we had. The fact that there are different types of shadows in Unreal, which right now doesn't impact us yet, but just be aware that that's happening. And then the basics about performance, as well as a brief word on quality.